Hello, grade 11 students. I wish you are safe and I just hope to see you soon in school, face to face. But at some point, we have to make sure that there are some materials that we have to revise and we have to continue as much as we can, of course. That's why I'm going now to make a quick revision for the first part of our lesson that I have explained in class, and I'm going to continue the other part. First of all, let's remember together what's the meaning of a quadratic equation. A quadratic equation is an equation with one unknown, x. It should be in the form of ax squared plus bx plus c equals to 0, where a, of course, is not 0, because if a is 0, it won't be a quadratic equation. It will be a first degree equation. A, b, and c are called the coefficients of the equation. For example, 2x squared minus 3x plus 5 equals to 0. This is a quadratic equation of second degree. We have also 5x squared plus 5 equals to 0. This is also a quadratic equation where b in this case is 0. It's possible, but a cannot be 0. We also explained in class that in order to find the solution of the quadratic equation, we need to find the discriminant of the quadratic equation, which we call delta, and delta is b squared minus 4ac. And we have three cases. If delta is positive, then we have two roots. The first root is minus b minus radical delta over 2a, and the second root is minus b plus radical delta over 2a. The second case, delta equals to 0. In this case, we have one root, or one double root, where x1 is the same as x2. It's minus b over 2a. And if delta is negative, we don't have roots, or in another word, we don't have real roots. Okay? As an example, suppose we have 8x squared plus 2x minus 3. A is 8, b is 2, c is minus 3. Delta, in this case, is b squared minus 4ac, which is 100. Delta is positive, so we have two different roots, or two distinct roots, minus b plus radical delta over 2a, and minus b minus radical delta over 2a. So the two roots are half and minus 3 over 4. So those are the roots of the equation. The second example, we have x squared plus x plus 3 equals to 0. A is 1, b is 1, and c is 3. Delta is b squared minus 4ac, which is minus 11. So since delta is negative, no real roots. Now, what do we mean by the sum and product of the roots? If we have two roots, x1 and x2, the sum is x1 plus x2, which is minus b over a. And the product of the two roots, x1 times x2, is c over. If we have the sum and the product of the roots, we can write the quadratic equation in the form of x squared minus sum x plus product equals to 0. This is convention. Every time you have the sum and the product, you have to replace them in this equation, so you get the quadratic equation as shown. Our lesson is to find the sign of f of x. If delta is negative, then f of x takes the sign of a. If a is positive, then f of x is positive for every x. If a is negative, then f of x is negative for every x. If delta equals to 0, then in this case, f of x takes the sign of a except for x equals minus b over 2a. Okay? So if delta is positive, then we have two cases. We have two roots, right? x1 and x2. If a is positive, then the sign is below. If a is negative, then the sign is below. So what I'm trying to say is, every time inside the root, okay, we have opposite sign of a. Inside the two roots, we have opposite sign of a, and outside the roots, we have same sign as a. If a is positive, then inside the root we have negative, and outside the root we have positive. If a is negative, inside the root it's opposite, so it means positive, and outside the root same, which is negative. Let us do an example Okay, I'm going to take the example of example 1, where we already calculated the roots, x equals half and x equals minus 3 over 4. How do we find the sign? It's very easy. We draw this table. Okay, the two roots are minus 3 over 4. We put them in increasing order, and the second root is half. Okay, both of them are roots for f of x, or for the quadratic equation. Every time you have to put if a is positive or negative. In this case, a is positive. So inside the root, opposite sign of a. Outside the root, same sign as a. Okay? So we say that this quadratic equation is positive for minus infinity, minus 3 over 4, union 1 over 2 plus infinity. And this quadratic equation is negative between minus 3 over 4 and half. That's how we study the sign of the quadratic equation.